Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over some of the relationships that exist between the equilibrium constant and the chemical equation. So let's get into this. So there are three relationships, three things you need to remember to do to your equilibrium constant if you do this to your equation. So what are those three things? So first, if you reverse your equation, you have to invert the equilibrium constant. So what that means is that the new equilibrium constant for the reversed equation will just be the inverse of the equilibrium constant of the original equation. So if I have an example here, so my original equation is 2a plus 3b gives me c as a product. And so the equilibrium constant for that reaction is, again, remember the concentration of the product raised to its coefficient, which is 1. And then on the bottom are the concentrations of the reactants raised to their coefficient. So we have 2 for A and we have 3 for B. So this is the equilibrium expression for this equation. If we were to reverse this equation, so now C is a reactant, and that's going to produce 2A and 3B. So if we were to write the equilibrium constant for this equation just like we normally do, right? So these would be the products. So we're going to write the concentration of the products raised to to their coefficients. So A is raised to 2, the concentration of B is raised to 3, and then we have the concentration of C on the bottom. You'll notice that between these two equilibrium expressions, K2 is just the flipped or inverse of K1. So we could write that as 1 over K1. So to find the equilibrium constant for the reverse reaction, you just take equate the constant of the original and just take the inverse of it, and that'll give you uh, the the constant for the reverse reaction. All right, so for the second one, uh, if you multiply the coefficients of your equation by a factor, right? Maybe you multiply by 2 or 3 or 1/2 or whatever that factor is, you have to raise the equilibrium constant of the original equation by that same factor. So here we have an example. So here's my original example. So here I have K1 again. So this reaction has an equilibrium expression K1 and therefore some constant for this reaction at a particular temperature. So if I take this equation and I multiply by some constant n, some coefficient, some factor n, right? So instead of having 2, I have 2n. 3, instead of 3, I have 3n, and instead of having 1, I just have n here. Well, what would the new coefficient be? What would the new equilibrium coefficient be for this one, or equilibrium constant? So K3, if I write K3 like I normally would, right? So then the product is on top, so the concentration of C raised to the n power, and then A and B are on the bottom, concentration of N raised to the 2N power, and B, concentration of B raised to 3N power. Then I can take this expression, since they all have N as part of their coefficient, part of their exponent, then I can pull N out like this. So I can pull N out. So this would be like taking to the N power. So if I take out the n and I put it outside the parentheses, right? What do I have inside the parentheses? I have the same expression I have here for K1. So the expression of K1 is raised to the n power. So this is the way it ends up being. So if I have my equation, if I multiply that equation by some factor n, then all I do is I take the equilibrium constant of the original equation and I raise to that by the same factor. So K1 is then raised to the factor of n, and I get my new equilibrium constant for that new equation. Okay, for number 3, the third and last relationship I'm going to go over is that if you add equations together, you multiply the equilibrium constants for those reactions to get the new equilibrium constant of the new reaction that you got when you added them together. So here I have an example. So here I have A is in equilibrium with 2B, 2B is in equilibrium with 3C. So if I add these two together, I get A is in equilibrium to 3C. So the 2B's kind of cancel out. So 2B as a product becomes a reactant to make 3C. So that gets canceled out, and I get A in equilibrium to 3C. So this is my resulting equation that I get from adding these two together. So what would be the new equilibrium constant for this? Well, I could set up my equilibrium expression, my equilibrium constant expression, call that K3. And so I have 3C on the bottom. So I'm sorry, I have 3C as a product. So then this is a product that's going to go on top of the expression. 3 is the coefficient, so 3 is my exponent here. So I have the concentration of C raised to the third power. And since this is a reactant, A is going to go on the bottom, so concentration of A on the bottom. So this is the expression of my resulting equation from adding these two. Well, what are the expressions for these two? Well, I do the same thing as I've done before. So for K1, for this reaction, again, product is on the top, so I have concentration of B raised to the second power, and I got A on the bottom, concentration of A raised to the 1 power, since this is a coefficient 1. So this is the expression for K1, and then the same thing for this one. So 2B goes to 3C. So again, so the expression here is this is the product 3C. So 3C, concentration of C goes on top, raised to the third power here. And then 2B goes on the bottom. So the concentration of B raised to the second power. So these two expressions here, K1 and K2, if you multiply these together, right, the B to the 2 power, concentration of B to the second power, they cancel out when you multiply. So you end up getting C to the third power, concentration of C to the third power over the concentration of A, which is exactly the expression you would get from here. So what this is showing you is that if you know the equilibrium constants for two equations and you add these together to get a third equation, and you want to know what the equilibrium constant of your resulting equation is, all you do is you take the two equilibrium constants you know from these two equations that you added together and just multiply them, and that resulting constant will be the equilibrium constant for your resulting equation. So those are the three main relationships between your equilibrium constant and the chemical equation. I hope you enjoyed this video. I hope you learned something from this. If you did, please smash that like button, subscribe to my channel, hit that notification bell so you can be notified by other videos I put out. Put a comment in the comment section. Let me know what you think and if you have any questions. Thanks for joining me, and have a great day.